In our video today, we want to look at another problem on vectors. We are given the position vectors r, s, and t in the rectangular coordinate system that we call x, y plane. Now let's look at vector r that's equal to 5 I hat plus 3 j hat. Then vector s is given 8 I hat minus j hat. And vector t is given 11 I hat plus minus 5 j hat. Now the first question said to show that the vectors are, the points r, s, t are collinear. Now, how can we show that the points are collinear? That is only if the 3 points are on the same straight line. And if these 3 points are on the same straight line, it simply means that the adjacent points r, s, and st are equal. So let's see whether that is possible. We know that rs will be vector s minus vector r, which will be equals to 8 I hat minus j hat, then minus vector r, which is 5 I hat plus 3 j hat. So if we open this bracket, we are going to have 8 I hat minus j hat minus 5 I hat minus 3 j hat, because minus times plus will be minus. So 8 I hat minus 5 hat will give us 3 I hat. Then minus j hat minus 3 j hat will give us minus 4 j hat. Now let's try for vector st and see whether the two lines are parts of the straight line rst. So let's see st, which we know will be equal to vector t minus vector s, and that will be t is 11 I hat minus 5 j hat, then minus vector s, that is 8 I hat minus j hat. So which should be equal to 11 I hat minus 8 I hat, then minus 5 j hat, minus is plus, that will be plus j hat. So 11 I hat minus 8 will give us 3 I hat, then minus 5j plus j will give us minus 4j. Since rs is 3 I hat minus 4j hat, and then st is also 3 I hat minus 4j hat, simply means that rs and st, let me add this together, they are on the same line, because this should give us rst, same line. So you can say it's equal to vector rt, that is on the same straight line. Now let's look at the second part of the question, which is more attractive. Yes, welcome back to our video. We want to come. Okay. So from what we have done so far, we started to solve question 2 by expanding what we were given, and then bringing in vector r and vector t, like you can see on the board. And from here, we expanded the brackets and then equated all the vectors that have i's together. From 15, remove the I, and then pick 5 pairs of 1 that had I, and 11 pairs of 2 that had I. That was equation 1. And then for all the vectors that had j, we brought them down 9, and then 3 pairs of 1 that have j, and then negative 5 pairs of 2 that have j. Then we solve this to find the values of pairs of 1 and pairs of 2. And then we have to multiply equation 1 by 3 and equation 2 by 5, and that gave us this. Then we subtracted equation 3 from equation 4, and that our case of 2 became 0. Plug in 0 for case of 2 in equation 1, where we have 11 here. And so that took us to having 15 is equals to 5 case of 1. And then we divided 15 by 5, and our case of 1 became 3. So from the solution now, it means that our case of 1 is 3 and our case of 2 is 0. Thank you so much for watching.